Here in this course, we will take a data set and we will apply feature engineering techniques on it to get cleaner and more useful data set. And we will train our machine learning model on this new data set. Our machine learning model will be very happy during a training because it will be easy for it to learn the concepts and the patterns inside this data set, and its results will be very good. In this course, firstly, we will talk about the features and what is the type of each feature. After that, we will learn how to impute the missing values in our data set to convert our data set into complete data set. And after that, we will learn how to do feature selection and dimensionality reduction, and how to construct new features, and how to learn new features. We will learn all these things in this course. So, what are you waiting for? Join us. Hi, in this lecture we will learn how to create a notebook to write and execute our code. Here we will use Colab notebook. So we should type Colab here. You should have a Gmail account. Now you should click on a new notebook. And here's your notebook. You can change its name, for example, to FG Feature Engineering. Okay. And now what we will do, we will load our data set to this notebook. We will click here. Now I have this data set here. Firstly, I will put it in my Google Drive. Again, you should have a Gmail account to create a Google Drive. I will drag and drop these files in my Google Drive. Here, let's create a folder. Right click and create a new folder. Let's call it data set. Okay. Now let's enter to this folder. Now we just need to drag and drop them here. This one and this one. That's it. Now let's go back to our notebook. Let's click on this symbol here and click on connect to Google Drive. We will search about dataset folder here in this drive folder. We just need to click on it, and here is our dataset folder, and you will see two files inside it, train file and test file. That's amazing. In the next lecture we will talk more about what is this data set. Okay, let's write very simple code to make sure that this notebook works. So let's write print, for example, 2. This one will display number 2. Let's run this cell by clicking on this symbol, and that's right. Okay, thanks for watching. Hi, in this lecture we will learn how to read our dataset. So firstly, we should import pandas package as PD, and we will click on run. And now let's read our dataset. Here our dataset train CSV. We will click on these 3 points here, and we should click on copy path, and that's it. Now what we will do, we will create a variable called train, which is equal to pd.read CSV, and here we should put the path of our train.csv file. So as you can see here, and now we should click on run, Now let's display the contents of this variable. As we can see here, our dataset, it is just a table. We call it tabular data, which has rows or samples and columns or features. That's amazing. If you want to display few rows, you just need to type train.head like this, run, and here's the result. In the next lecture, we will talk about each column in this table. Thanks for watching. Hi everyone, in the previous lecture we learned how to put our data set in our Colab notebook. Now we should ask ourselves if our data set is structured data set or unstructured data set. What is the meaning of structured data set? It means that our data set, it is tabular data set, which has columns and rows. Okay? Each column in the dataset represents a specific feature, and each row in our dataset represents a specific sample. Okay? So, now what is unstructured data? Let's say that our dataset, it is unstructured dataset. What does that mean? It means that our dataset, it is not tabular dataset. In this case, you should convert it into structured dataset. Okay? Now let's see our dataset, if it is structured dataset or unstructured dataset. As we can see here, our dataset, it is tabular dataset or structured dataset. So we don't need to do any transformation because our dataset by default is structured dataset, tabular dataset, which is good. Now let's take an example for unstructured dataset and how to convert it into structured dataset. Let's say that we have a dataset for reviews. Here is the first review and the second review, etc. Each review, it is just a text. Okay? We should extract features from these texts. Okay? To be able to convert this dataset into structured dataset, to convert it into table. Here is one way to do that. Firstly, we will create this table here. The first column represents the review ID. Here is the first review, the second review, etc. And here is the text or the review itself. And here this column, it is sentiment column, which tell us if this review, it is positive or negative. And here is another feature, which is word count feature. This will tell you the number of words in this review, which in this case equal to 7. And the last column, the last feature here in our tabular data, in our structured data, will be review length, okay, which represents the number of characters in our review, which is 47. So in this case, we converted our reviews into features, right? So we converted our unstructured data to structured data. That's amazing. Let's take another example of unstructured data. Let's say that our data set has audio files, audio 1, audio 2, audio 3. Okay? It is unstructured data. We should convert it into tabular data or structured data. How can we do that? We will use special libraries like LibRosa to extract features from these audio files. By using this LibRosa library, this LibRosa package, you will be able to extract these features from your audio files. So here's the first column in your structured data, which is audio ID, audio 1, audio 2, audio 3. And here's the first feature, MFCC1, the second feature, MFCC2, and here we have also duration, feature and pitch feature. So now we converted our unstructured data into structured data. And we can extract more features actually, not just these 4 features, but more than that. So we can say that we can convert any unstructured data to structured data. Let's go back to our data set. As I said previously, our data set it is by default structured data. And here's our data set, which has rows and columns. Okay. Our data set called Titanic data set. Each row in this data set represents a passenger. Okay. As an example, here is passenger 1. And here this feature will tell us if this passenger survived or not. So its value 0 or 1. If it is 0, it means that the passenger didn't survive. If it is 1, it means that this passenger survived. Okay? And we have many other columns in this data set. We will talk about them in the next lecture. Thanks for watching. Hi. In the previous lecture, we found that our data set it is structured data set. So what is next? Now what we should do actually, we should pass it through each feature in our data set, and we should specify the type of each feature. Okay? For example, let's take the first feature here. We should check if this feature is nominal feature or ordinal feature or interval feature or ratio feature. Let's take the first option, nominal feature. What is the meaning of this? Here is a very simple example to understand what is nominal feature. Let's say that we have a tabular data with just 2 columns. The first column it is name column. It's like ID column actually. And the second column it is favorite color column or favorite color feature. Here in the first column we have this name Emma, the first row in this data set. This person, the favorite color of this person it is red. Okay? While the favorite color of this person it is blue, and the favorite color of this person Nuh it is green, and the favorite color of this person Olivia it is yellow, and the favorite color of this person Eva it is pink. Okay, now this feature, favorite color feature, it is nominal feature. Why it is nominal feature? Because these categories, red, blue, green, and yellow, and pink, there is no ordinal relationship between them. Okay? We can't say that red it is greater than blue, or blue greater than green, or blue less than green, or green worse than blue, or green better than blue. There is no ordinal relationship between them. So the type of this column it is nominal column or nominal feature. In other words, they are just different choices and there is no ranking. Okay, it is very easy. Now let's specify the nominal features in our Titanic data set. Okay, passenger ID it is nominal feature. Each passenger has its own ID, its own number. So we can't say this passenger is greater than the second passenger or something like that. There is no ordinal relationship between them. And this column, survived column, the type of this column actually it is not a nominal column, because here 0 it means not survived, while 1 it means survived. We can say now that survived it is better than not survived, right? So there is some kind of ordinal relationship between the categories of this column. and we will learn what is the type of this column in the next lecture. We have also this P class. This column represents the class of the passenger's ticket. So we can say that first class, of course, it is better than third class, and class 2, of course, it is better than class 3, and something like that. So this column, it is not nominal column. We have this column, name column. Here, this column, it is nominal feature because this name, it is not related with this name, and this name not related with this name. We can say this name is greater than this name or something like that. Each one has its own name. Each one has, or names are simply labels and don't imply any ranking or ordering. We have also this column, sex column. It is actually nominal feature because here we have just two categories, male category and female category. We can say male better than female or male greater than female, so of course it is. And we have this column, H column. Actually this column has continuous values. It doesn't have categories, so it is not nominal feature. And we have this column also. It is not nominal feature because here we have two categories, 0 and 1. Because if the value of this feature for this passenger equal to 0, it means that this passenger hadn't sibling with him aboard the Titanic. If the value of this feature equal to 1, it means that this passenger had a sibling with him aboard the Titanic. Okay? There is ranking here, so it is not nominal feature. We have also this feature, parch feature. This one, it is also not nominal feature. Actually, this feature represents the number of parents and children the passenger had aboard the Titanic. So we can see that there is some kind of ranking here. Okay, we have ticket feature. This column, this feature, it is nominal feature because each passenger has its own ticket number. Okay. What about this feature, fare feature? This one represents the amount of money a passenger paid for a ticket. So we can say it is somewhere it is continuous feature. So it is not nominal feature. This one is, we can say it is smaller than this one, and this one is greater than this one. Okay. Cabin. Here this feature represents the cabin number of each passenger. So it is nominal feature. Finally, we have this feature. This feature, embarked feature, it is nominal feature. And finally, we have this column, embarked column or embarked feature. This feature, it is nominal feature. Why? Let's take the first category in this feature. Let's take this passenger. The value of this feature for this passenger is as, what is the meaning of this? This as here it means Southampton Port City, okay? Which means it is a place where ships can wait at the dock to load or unload passengers or goods, okay? And see here it is another port city. So we can't say that this one greater than this one or this one greater than this one. So it is nominal feature, okay? In the next lecture, we will learn what is the advantage of knowing the type of each feature. Thanks for watching. Hi everyone. In this lecture, we will learn how to visualize our nominal features, which is something important in feature engineering. Okay, so firstly, we read our data set. Here now what I will do, I will display a brief description about my data set. So I will type train.info, okay, and I should click on run here, and here's the result. Here is the total number of samples in my dataset, which is equal to 891. And here this description will tell me if there are missing values in my features or not. So firstly, I have this feature, passenger ID feature. As you can see here, the total number of non-null values equal to 891, which is equal to the total number of samples. So there are no missing values in this feature, which is obvious actually, because this feature actually, this passenger ID feature, it has a unique identifier for each passenger, okay, and it will also give you the data type of this feature. Actually, this feature has integer numbers, so the data type of this feature equal to integer 64, and I have this feature also, survived feature, and here the number of non-null values equal to 891, which means there is no missing values here, which is also integer 64 data type. We have also P class, and here this P class feature, the number of non-null in this feature equal to 891, which means there is no missing values here, and the data type of this feature equal to integer 64. And here we have this feature, name feature, which there are no missing values, and the data type of this feature, it is object. We have sex, which is also object here, but we can change it to integer 64. It's up to you. We have also age feature. As we can see here, the number of non-null values equal to 714, which means there are missing values. The number of missing values here equal to 891 minus 714. Okay, the data type of this feature equal to float 64, because there are fractional numbers in this feature. We have SIB-SP, the number of non-null values equal to 891. The data type of this feature equal to integer 64. We have PARCH, the number of non-null values equal to 891, and the data type equal to integer 64. We have ticket, the number of missing values here equal to 0, because here we have 891 minus 891, the result equal to 0, which is also object. We have fair feature, the number of non-null values equal to 891, and the data type equal to float 64. And we have cabin, the number of non-null values equal to 204. So there are a lot of missing values, because we will get large number from 891 minus 204. Okay, we have embarked feature, the number of non-null values equal to 889. So 891 minus 889, the result equal to 2, which means that we have 2 missing values. Now let's check the number of missing values inside each feature. We can do that with just one line. Firstly, we should type the name of our data frame, which is a train.isNull. Okay, we will open and close these parentheses. Dot sum, and that's it. Now let's click on run, and here is the result. We will get this table. And as you can see here, the number of missing values for passenger ID equal to 0, the number of missing values for survived feature equal to 0, and here as you can see the number of missing values for this age feature equal to 177, and the number of missing values for this feature cabin equal to 687, and the number of missing values for this feature impact feature equal to 2. That's amazing with just one line. Now let's visualize one of the nominal features that we have in our data set. For example, let's take sex feature. Okay, so let's create another cell here in this notebook. We again just need one line to visualize our sex feature. We just need to type train, the name of our data frame, our data set. We will open these square brackets and we will put the name of the feature that we want to check, which is sex name. Now you should keep in your mind that because there are categories in this feature, so we can use this method, value count method. Value counts method. Let's see the results of this method. Here is the result. It will create this very small table. In the first column you will see the categories of this feature, sex feature, and the second column will represent the count. So here, for example, 577, it means around 577 of the passengers are male. And here this 314, it means that around 314 of the passengers are female. But we want to visualize these numbers actually, so we should put dot again, plot method, okay, and here we will make kind argument equal to bar. Okay, so we will create bar chart. This chart we can use it just with features that have categories. Okay, so let's click on run, and here's the result. That's amazing. Here's the number of male passengers, and here is the number of female passengers. Okay, let's take another nominal feature. For example, let's take this feature, cabin feature. It is nominal feature. Okay, I put this feature here, and here is the result. And as you can see here, the number of categories in the x-axis, or in this feature actually, they are a lot. So at this case I will take the first 5. So how can I do that? I will remove this part here. I will type dot sort values. Okay, and here I will make ascending argument equal to false. Okay, which means that I will sort them in descending order, which means that I will sort the counts in descending order. Okay, from the largest one to the smallest one. Dot. Here I will take, for example, the first 5 categories. Dot head 5. Okay, and now what I will do, I will plot them. Okay, and again I will specify the kind of my plot, which is bar plot. Let's run this again, and here is the result. Okay, as you can see here, we have 4 passengers in this cabin, and we have also 4 here and here, and we have 3 passengers here and 3 passengers here. Okay, so the rest cabins, we can say they are 3 or less than 3, okay, but not more than 3. Let's open another cell. Here is another plot that we can use it with nominal features, which is pi plot. To use it, we just need to make kind argument equal to pi, okay, and that's it. As you can see here from this plot that most of the passengers are male, okay, that's amazing. So now we learned how to visualize the nominal features. Thanks for watching. Hi everyone, today we will talk about ordinal features. In the previous lecture we said that we should specify the type of each feature in our data frame. So how can we determine the ordinal features? It is easy. Let's say that we have this ordinal feature here, F1. This feature will have some categories, and there are some kind of ordinal relationship between these categories. For example, let's say that the categories inside this feature are cold, warm, and hot. As you can see here, we have some kind of ordinal relationship between these three categories. Okay. Now let's go back to our data frame and search about ordinal features. Here is our Titanic dataset. Here we have this feature, P class feature. Here we can say that the first class is the most expensive, followed by the second class and the third class. So as we can see here, we have three categories, 1, 2, and 3. And there are some kind of ordinal relationship between them. So this feature, it is ordinal feature. Now let's visualize this column and extract some statistics from it. Now let's visualize our ordinal feature. Firstly, let's create a cell. Now what we will do, firstly, let's use value counts to find the number of samples that belong to each class, each category. Here we should put the name of our ordinal feature, P class, like this. And here's the result. As you can see here, around 491 of the samples belong to class 3 and around 216 samples belong to class 1 and around 184 samples belong to class 2. Now let's create pie chart. Here is our pie chart. Firstly, we will take the data frame that I created using value counts, and we will sort the values in ascending order, and we can remove this one because we have small number of categories. And finally, we should specify the type of our plot, which is pie plots. As you can see here, most of the samples belong to class 3. We have another chart that related with just ordinal features and numerical features, and we can't use it with nominal features, which is box plot. Let's use this plot. We just need to type box here, and that's it. And here's the result. And even if you can use this plot for ordinal features, it is meaningless actually, because it is designed to work with numerical features. And you can also use bar chart with ordinal features if you want, like what we did with nominal features. That's it for today. Thanks for watching. Hi everyone. Today we will talk about interval features. Interval features are numerical variables where the difference between values is meaningful, but there is no true 0 point. Let's take an example to explain what we said previously. Let's say we have this feature, temperature feature. This feature actually it is interval feature. Why? Because there is no 0 point here in this feature. As you can see here, this 0 here, 0 Celsius, it just means the temperature at which water freezes under normal atmospheric conditions. It doesn't mean the absence of temperature. Now let's say that we have two temperatures, 40 Celsius and 20 Celsius. Here in interval features, here we cannot say that 40 Celsius is twice as hot as 20 Celsius because the Celsius scale has no true 0 point, which means that multiplying or dividing interval features doesn't make any sense. But you should know the difference between values is meaningful. In other words, we can add and subtract the interval features because the subtraction and addition give us meaningful values. Let's search about interval features in our Titanic dataset. The first feature is nominal feature. The second feature is also nominal feature. This feature it is ordinal feature. As we said previously, this one it is nominal feature. This one it is nominal feature. This one age feature. Let's test this feature to determine if it is interval feature or not. When the value of this feature equal to 0, what does that mean? Here when the value of this feature, this variable equal to 0, it means that there is no age. In other words, this feature has 0 point. So we can't consider it as interval feature. Now let's talk about this feature. Siblings feature. This feature will specify the number of siblings with the passenger on the Titanic. Firstly, when we take the difference between the values of this feature, the results will be meaningful. For example, the difference between 3 and 2 is 1, which means 1 sibling. Now let's check the 0 point. Does this feature has 0 point or not? When the value of this feature equal to 0, it means that there are no siblings with the passenger. Okay, so it is true 0 point. In this case, this feature is not interval feature. What about this feature, part feature? Let's see the values of this feature firstly. Let's type train parch.unique. Here are the values of this feature. This feature will specify the number of parents or children with the passenger on Titanic. Firstly, the difference between this value 1 part, which means 1 parent or child, and this value 2, which means 2 parents or children, it is meaningful difference of 1. But when the value of this feature equal to 0, it means the person had no parents or children. This represents the absence of parents or children, which is a true 0 point. At this case, this feature, it is not interval feature. Okay? And the same thing with this feature. This feature, it is a nominal feature, and this feature, it is not interval feature, because when the value of this feature equal to 0, means the passenger paid no money for the ticket. This represents a true absence or a zero fare. Okay. This feature represents the location on the ship where a passenger stayed. So it is nominal feature. And the last one, it is also nominal feature. Unfortunately, we don't have any interval features in our Titanic dataset. So let's create very simple dataset with just one column which has interval feature, and let's learn how to visualize this feature and extract some statistics. Okay. Firstly, let's create our data set. Here we will create this dictionary, data dictionary. We will open these square brackets. The first feature, it is city feature, and here are the values of this feature, comma. Here is the second column in our data set, which is temperature Celsius column, and here is the temperature of each one of these cities, okay, in Celsius. Now let's run this cell. And that's it. Now we have our data set, which has this interval feature, temperature Celsius interval feature. Let's add none values here. Okay. Let's say that we don't have the temperature of China, for example. And yes. Now let's run the cell. Now we have none value. Firstly, you should keep in your mind that you should remove these non-values before visualization. Firstly, let's check the number of missing values in our dataset. We just need to type the name of our dataset dot is null dot sum. And as you can see here, the first feature doesn't have any missing values, while the second feature has just one missing value. Okay, now let's remove this missing value. We will just remove the row of this missing value. Okay, we just need to type the following: df.drop, like this, and we will open these parentheses, and we should type any place equal to true. So now we don't have any missing values in our data frame. Now let's go and visualize our temperature Celsius column, our interval feature. Firstly, we will use histogram plot to visualize our temperature Celsius column. So we just need to type data frame, and here we should pass the name of our interval feature dot histogram, and that's it. Here is our plot. This bar here, it means that we have just one sample belong to this temperature, and one sample belong to this temperature 10 Celsius, and one sample belong to this temperature 20 Celsius, etc. If you want to extract some statistics from this column, it's easy. We just need to use a very simple method called describe, like this, and that's it. Here is the result. Here will give us the mean or the average temperature. Here pandas added all these values together and divided them by the number of samples in our data frame or the number of rows, and here is the result, which is equal to 18. And here we have the standard deviation and many other things like the minimum temperature, the maximum temperature. Okay, that's amazing. Here the temperature of around 25% of our samples below than 12 and around 50% of the samples lower than 18 and around 75% of the samples lower than 25 Celsius. That's amazing. Thanks for watching. Hi everyone. Today we will talk about ratio features. Firstly, you should know that ratio features have meaningful differences and the true zero. For example, weight feature, it is actually ratio feature because this feature has a true zero. For example, 0 kilogram, it means that absence of the quantity. Okay, and here we can't say -1 kilogram or something like that. Okay, it is not possible with ratio features. And in ratio features we can say that this value 5 kilogram, it is half 10 kilogram, which means that in ratio features we can divide and multiply these features and we will get meaningful things. Now let's search about the ratio features in our dataset, our Titanic dataset. As you can see here, we have this feature, age feature. This one has a true 0, so it is a ratio feature. And this one also, and this one also. Okay, now we will learn how to visualize these ratio features. Firstly, let's create two features. Here we have the first feature, which is categorical feature, low, medium, and high. The first sample is low, the second sample is medium, the third sample is high. And we have this feature income feature, which is actually a ratio feature because it has 0 or a true 0. And here's the first income for the first sample, and the second income for the second sample, and the third income for the third sample. And now what we will do, we can use bar chart here and we will get this plot here. This y-axis, it is the average income, and the x-axis, it has these three categories, low, medium, and high. And for the first category, low category, we will have this income 1000, and here is the result. And the same thing for the second category, medium category, we will have this 5000, etc. And here we can specify the colors of these bars. The first one will be red, the second one will be blue, and the last one will be green. And here we can put the label of the x-axis and y-axis, and we can make a title for this plot. And here we will visualize this plot. We can also use a scatter plot with ratio features to visualize them. As you can see here, we will use Seaborn library. Okay, here we will create random data or random feature. This feature will have random values, and we have another feature which is weights feature, and we will create this feature based on heights feature. Okay, now we have two features, and as you can see here, these two features are ratio features, and now we can visualize both of them in the same plot. So firstly, let's create our data, and now what we will do, we will type SNS.scatterplot, and here we will pass the name of the x-axis and the name of the y-axis and the data, which is our data frame here. And here we can put the title of our scatter plot, and here we will visualize our plot. Let's run the cell. As you can see here, we have this plot. The y-axis, it is the weight axis, and the x-axis, it is the height axis. And now we visualize these two ratio features in the same plot. And here we can see that the relationship between the weight feature and the height feature, it is linear relationship. Most of the time when we increase the height, the width will increase as well. You can also use line chart and histogram. It's up to you. Thanks for watching. Hi, in the previous lecture, we explained each feature in our Titanic dataset, and we classified our features into 4 types: nominal, ordinal, interval, and ratio feature. And we even visualized some of them using bar plots, histograms, etc. So what we did previously was just the first step in something called Exploratory Data Analysis, EDA. EDA is simply looking at your data to understand it before doing anything. Imagine you are a chef who just got a basket of ingredients. Before you cooking, you check what ingredients you have, see if anything is rotten or missing, smell and taste a few things, think about what flavors go together. We call all these steps EDA, Exploratory Data Analysis. Here we will use Manus AI agent to do exploratory data analysis for us, which will speed up the process of EDA. In the next lecture, we will learn how to use Manus to do EDA. Thanks for watching. Hi. In this lecture, we will learn how to create a new account in Manus AI agent. Firstly, you should put Manus here, and let's go to Manus official page. Click on sign up. If you have a Gmail account, you just need to click on this button here. Here I put it all the required information, my name and my email and my password. Let's click on this button and let's put this one here, verify. Now we will receive a verification code on our Gmail account, this one here. Here is the verification code. Let's copy this code and put it here. Let's click on verify. Here we should put our number, our phone number. After putting your number here in this field, click on send code and you will receive a code on your mobile phone. Click on verify code and that's it. Let's click on get started. As we can see here in this field, this text field, we should give Manus a task to work on. And our task is to do EDA, Exploratory Data Analysis on Titanic dataset. Actually here we are using free plan, but you can upgrade your account to get more features. Here in this free plan we have 300 credits each day. In the next lecture we will start using Manus to do EDA. Thanks for watching. Hi, in this lecture we will use Manus to do EDA. But before doing that, let's talk more about Manus, how it works. As we said previously, Manus, it is an AI agent which has its own operating system, which is Ubuntu. This AI agent, it is able to control this operating system, which is similar to what we do with our computers. It is able to open a browser and search about any topic, create a code and run it, and all these things. Here in this text window, we will put our prompt. We will put what we want from Manus to do. Firstly, we should select agent. Okay? And now we will upload our Titanic data set here. Let's click on choose local files. Here is our Titanic dataset, train.csv file. Here is our prompt. This table contains the Titanic dataset. I would like your help in performing an exploratory data analysis EDA to better understand the data. Additionally, I would like assistance in creating a website to showcase this data. The design should be high-end, clear, and fancy with rich and interactive charts. Let's click on this symbol here. As you can see here, here is the first task for our Manus AI agent. Now Manus is working. As you can see here, he is writing a code and use this terminal and writing commands and all these things. Here Manus is creating these plots, which is amazing. And as you can see here, Manus will tell you what it wants to do before doing anything in its operating system. Okay? For example, data loading and initial exploration. Here firstly checking current directory for the train, and here it will use his terminal to do this thing. And if you want to check what it did previously, you just need to click, for example, on this step. You will see what it did here and here and here. That's amazing. It will take some time until creating the final result, so we will wait it. Here we will click on allow for this task, allow Manus to deploy the website publicly. Okay. Now here is our website, Titanic Dataset Explorer website. We have a lot of things here. Here we have in our dataset around 891 passengers. Around 38.4 from the passengers survived. Okay. We have 3 classes, 3 ports, and we have all these plots, age distribution. Okay. The ages of most of the passengers between 20 and 40. What about fare distribution? The range of fare distribution between 0 and 100. Let's go to demographics. Breakdown of passengers by class, gender, and embarkation port. First class 216, or 24.2% of passengers belong to first class, and 20.7% of passengers belong to second class, and 55.1 passengers belong to third class. The first class, it is very expensive, and the third class, it is the cheapest one. Let's go to survival analysis. As you can see here, around 62% of the passengers in the first class survived, which is a very high percentage, and around 47% of the passengers in the second class survived, and around 24% of the passengers in the third class survived. So I can say that people which have a lot of money, their survival probability will be high compared to the rest. And as you can see here also, around 74% of the female passengers survived, which is very high percentage compared to male passengers. 19% of male passengers survived, which is very low percentage. And we have also survival rate by embarked. You can also look at it. Finally, key insight. Let's see the key findings. Important insights from the Titanic dataset. Women and children first. Female passengers had a 74% survival rate compared to 19 for males. Okay. Class matters. First class passengers had a 63% survival rate vs 24% for third class. Okay. Age distribution. Most passengers were between 20 and 40 years old. That's amazing. We understand a lot of our dataset just by writing a good prompt to Manus, and Manus did all these things for us. That's really amazing. You can do the same process on any structured data that you have. Dataset summary, overview of the Titanic dataset. Total records 891, survivors 342, non-survivors 549, missing age data 177. Alright. In the next section, we will start learn how to clean our dataset. Thanks for watching. Hi everyone. In this lecture, we will take an introduction about missing values. What are missing values and why we need to handle them? To explain the idea of missing values, firstly, let's say that we have this very simple data set with just three features. Feature 1, Feature 2, and Feature 3. And here is the first sample in our data set, the second sample, the third sample, etc. Now let's say that we want to pass these samples through our model one by one. Let's firstly pass this sample. When we pass this sample through our model will accept it without any problem. Why? Because we don't have any missing values for the features of this sample. Let's move to the second sample in our data set. When we pass this sample through our model will accept it without any problem. Why? Because we don't have any missing values in the features of this sample. Let's move to the third sample in our data set. When we pass this sample through our model will not be able to accept this sample as input to it. Why? Because we have missing values. The first feature in this sample is missing, not a number value. Okay? So our model will not be able to accept this sample as input to it. Why? Because we have missing values here. Actually, most of the machine learning algorithms can't work with not a number values or missing values. So we need to process these values before passing them to our model. And that's what we will learn in this section. Thanks for watching. Hi everyone. In this lecture, we will learn how to handle missing values in numerical features. In the first section, we saw that features can be divided into four types: nominal, ordinal, interval, and ratio features. And here you should know that the way of handling missing values in interval and ratio features is different from the way of handling missing values in nominal and ordinal features. So the first step here is to create a list which will have the names of the interval and ratio features in our dataset. Okay? We will call this list numerical features list. Here we have just four numerical features. Okay? Aged, fair, SIP, SB, pouch. All these features are ratio features because all these features have true 0. Now what we will do, we want to handle the missing values in these features. Let's create another cell. Now let's handle missing values for these four features and train a simple model on these features. Okay, let's do it. Firstly, we should import pandas package as PD, and we should import train test split to split our data into training and testing data. Okay, so we will type from scikit-learn.model selection import train test split. And now what we will do, we will import column transformer. Previously we saw that our dataset has nominal features, ordinal features, and ratio features. But here we want to handle just the ratio features. By using this column transformer class, we will be able to apply different pre-processing steps to different features. In this lecture, we will just use our numerical features, but in the next lectures, we will also use the nominal and ordinal features. So we need to apply different transformations to different features. And in this case, this column transformer from scikit-learn.compose will help us a lot. It may not seem important right now, but be patient. This will greatly improve your pre-processing pipeline. And now we will import pipeline from scikit-learn.pipeline. We will use this pipeline class to create a pipeline for pre-processing. To make the idea of pre-processing pipelines more clear to you, look at this image here. Here we have a data frame with two features, feature 1 and feature 2. And we want to convert the features of this data frame to something suitable for our model. Just for illustration, let's say that this model in this image expects that you should wash your features before passing them to it. So now you will create your pipeline, pre-processing pipeline. This pipeline will have just one transformation step, which is washing step. So now we have this pipeline with just one transformation step, washing step. We will pass our data, our table, our features through our pipeline. We will pass it firstly through this washing step, and after that we can pass our data to our model for training or testing. In our case, our model expects that the input to it should not have missing values. In this case, we will create a pipeline with handling missing values step, or we can call it imputation step. And actually, you can add more than one step in your pre-processing pipeline. So, if the model that you choose for training, it needs from you to apply many different pre-processing steps on your original data. In this case, you should put many transformation steps in your pipeline. And now we will import simple imputer from scikit-learn.imputer. We will use this class to handle missing values in our numerical features. And we should import a standard scaler, which is something that we will talk about it later. And we will import our machine learning algorithm, which is logistic regression model. There are many different machine learning algorithms. You can choose any one of them. Here we used this simple one to show you the effectiveness of feature engineering, to help you realize that good feature engineering, even with a simple model, can lead to great results. I know we have a lot of things we need to learn about, but trust me, we will explain all these things easily. Firstly, what we will do, we will just select these 4 columns from our dataset. So we will type the following. Firstly, let's create selected features. These features are the numerical features. We will select these columns from our trained dataset. And now we have this array. Here we want to train a model to perform a classification task to predict whether a passenger survived or not, based on these 4 numerical features of the given passenger. But to train this model, we need the actual answers for the training samples. So we will extract the target column from our trained dataset, which is survived column. Now we have the features and the targets. What we will do, we will split our dataset into train and test. Why? Because we need also to evaluate our trained model. So we need a part of our dataset for testing. How to do that? We will use a train test split function to do that. We should pass our features array, our target column, and the size of our test set. So we will type test size equal to 0.2, which means that I want around 20% of the samples in our original data set to be for testing. Okay? The rest samples will be for training. We will get X train, X test, Y train, Y test. We will use X train and Y train for training our model. We will use X test and Y test for testing our model. That's it. Now we will do very important thing here. Here we will build a pipeline to handle the missing values in our numerical features. How to do that? We will type the following: numerical transformer equal to pipeline. In this pipeline class, we have this argument, the steps argument. Here inside this steps argument, you should create a list and you should put the transformation steps inside this list. The first transformation that we want to apply on any numerical feature column is handling the missing values inside it. So firstly, we should put the name of this step. Let's open these parentheses. Here's the name of this step, which is imputer. And now we will put this simple imputer. And here we should specify the strategy of handling the missing values for this numerical feature. Here we will replace the missing values with the median value. Firstly, let's say that we have this feature, feature 1. In the first step, we should find the median for this column, this feature, and replace these missing values with this median. How to do that? Here's the first step, step 1. Firstly, in this step, we will order these values, okay, from the lowest to the highest value. Firstly, we should put 1, 5, and 6. And actually, we don't know this value, so we will not write it here. And now, what we will do, we will take the number in the middle, which is 5. This one, it is the median. What we will do now in this step, we will replace the missing values with this value. So here is our new feature after doing imputation. Okay. So this is the first step in our numerical transformer pipeline. What is the second step in this transformer pipeline? The name of this step is scalar step. Here we will use a standard scalar class for this step. This transformation, it is actually related with the algorithm that we are using right now, which is logistic regression algorithm. This algorithm expects that the input features to it should be normalized. Let's take an example to explain it. Let's say that we have a data set with just 2 columns. The first column is the monthly income, and the second column is age column. Okay? The range of values in the first column is between $524,000 per month. And the range of values in this age column between 20 and 50. Here are some of machine learning algorithms will focus more on the features with large values, which means that our model will depend on just the features with large values to make the predictions, and it will get rid the features with the small values, which is not correct, because sometimes these features with the small values might have very good patterns that we can use to make good predictions. So we need to make our model handle these two features equally. To do that, we will use this standard scalar to convert these ranges and make the ranges something similar to handle them equally. So, after passing each column through this step, now we will pass the output from this imputer step to the scalar step. And actually this step we use it just with numerical features. Now we created our pipeline object, numerical transformer pipeline. What we will do now, we will create this preprocessor. Let's say that we have a data set with categorical features and numerical features, like we have ratio features and nominal features, and something like that. Now we should apply the pipeline that we created previously just on the numerical features. How can we do that? We will use column transformer class to do this task. Preprocessor equal to column transformer. Here we will have this argument, transformers argument. Here we will specify the features that we want to apply our numerical transformer pipeline on. So firstly we will put numerical, which is the name of this transformer, and after that we should pass the pipeline that we want to use, which is numerical transformer pipeline, and finally we should pass the names of the features that we want to apply this numerical transformer pipeline on, which is selected features list. Now let's say that you want to apply another pipeline on another set of features, like categorical features. How can we do that? Here we should create another tuple in this transformers list. We should pass the name of this transformer, the pipeline that you want to apply, and a list which has the names of the features that you want to use. We will talk more about this in the next lecture. Finally, we will create a pipeline which will have our preprocessor and our machine learning algorithm. Okay, so we will type model equal to pipeline, and here we will pass our preprocessor, which is the first step in this pipeline. This step will be responsible about working on the data and make it something suitable for our machine learning model. And the second step, actually, it is our model itself, our classifier that we will use to handle or solve this task. This classifier model will take the pre-processed data as input, and it will make a prediction for each sample in our pre-processed data. Now to train our machine learning model or our logistic regression model, we just need to type the following: model.fit, and here we should pass our x_train and y_train, and that's it. Now what we will do, we will pass our test data to our trained model and getting the predictions. This trained model didn't see the samples inside x_test previously during a training, so we can evaluate the performance of this trained model on these samples. Now the predictions from this model stored in y_prediction array. What we will do now, we will import accuracy score metric from scikit-learn.matrices. Now to get the accuracy for this model, we will type the following: accuracy equal to accuracy score function, and here we should pass y_test, which has the actual answers for these samples, and we should also pass y predictions, which are the predictions from our model on these test samples. And here is the accuracy of our model, which is 69%, which is good, but we want to make it even better in the upcoming lectures. So stay tuned. See you. Hi. In this lecture we will learn how to handle the missing values in our nominal and ordinal features. And we will use all our features to train our model. Firstly, we should import pandas as PD and train case separate from scikit-learn.model selection and column transformer from scikit-learn.compose. Here you will see the advantage of using column transformer. And we will import pipeline from scikit-learn.pipeline and simple imputer from scikit-learn.impute. And here we will import standard scalar, one hot encoder, and ordinal encoder from scikit-learn.preprocessing. We will talk about these two things here later. And finally, we should import our model, our logistic regression model, like this. Now, let's create these three lists: numerical features list, categorical features list. Let's call it, for example, nominal features list, and finally ordinal features list. Firstly, numerical features list will have the names of the numerical features: age feature, fair feature, arch feature, and sp feature. Now let's go to nominal features. This list will have the names of our nominal features: embarked feature, sex feature, cabin feature. And finally, we have just one ordinal feature in our dataset, in our Titanic dataset, which is P-class feature. That's it. Here we will create three pipelines: a pipeline for numerical features, and a pipeline for nominal features, and finally a pipeline for ordinal features. Let's see the first pipeline. We saw this pipeline previously in the previous lecture. This pipeline has two steps. The first step is this one here, which will handle the missing values in our numerical features. And the second one is a standard scalar, which will normalize the output from the first step. Okay? Let's go to the second pipeline. Let's call it nominal pipeline. And this pipeline will have also two steps. Here's the first step. In this step, we will handle the missing values in our nominal features. Here we will use most frequent strategy. You can't use median strategy here because you are working with categorical features. Let's see what we will do in this step. Let's say here that we have a dataset with just 5 samples, and this dataset has just one feature, which is sex feature. And here are the values of this feature: man for the first sample, man for the second sample. Here we have missing value for this sample, and here we have man for the fourth sample and woman for the fifth sample. We will use our imputer to replace this missing value with man category or woman category. Here our imputer with most frequent strategy firstly will count how many times the man category appears in our dataset. After that, it will count how many times the woman category appears in our dataset. And finally, our imputer will take the most frequent category. Here, the man category appears 3 times, and woman category appears 1 time. So, man category, it is the most frequent category. So, our imputer will replace the missing values with this category, with man category. The idea here is that the missing values will have a high probability of belonging to the most frequent category. For this reason, we replaced them with the most frequent category. Now we have another problem. These categories are strings, okay? They are texts. We can't pass them directly to our model. Our model expects numbers as input. To solve this problem, one way is to give a number for each category. For example, we will give number 1 to man category and number 2 to women category. In this case, we will get this new feature. with just numbers. The problem with this approach is that we converted our nominal feature into ordinal feature. Here our model will learn that women category it is higher than man category, which is wrong actually. To solve this problem, we will use one hot encoder. This one hot encoder will give each category its own column. So we will consider each category as a feature. So we have this man feature and women feature. Okay, and for the first sample belongs to the man category. At this case, we will put 1 here and we will put 0 here. And in the second sample, this sample belongs to the man category. So we will put 1 and 0. The same thing here. Here we have man category, so we will put 1, 0. And the final sample, the fifth sample, belongs to the women category. At this case, we will put 0 for the man column and 1 for women column. That's it. By doing this, you will prevent your logistic regression model from making wrong assumptions. And this is the first step in our nominal pipeline, which is one hot step. Here we will use our one hot encoder class and we will make sparse output equal to false and handle a noun equal to ignore. That's it. Let's go ahead to the final pipeline. This pipeline will work on our ordinal features. So ordinal pipeline equal to pipeline, and here we have just one step, which is impute step. Here we will also again use our most frequent strategy, okay, to handle the missing values. Let's see our P-class ordinal feature to see what is inside it. Here is our P-class column. As you can see here, this P-class column has numbers, okay, and of course missing values. So we don't need to convert its categories into numbers because they are numbers by default. But if the categories of your P-class are texts, so you should convert them into numbers, and at the same time you should keep the ordinal relationship between these categories, okay? For example, let's say that you have an ordinal feature which has 3 categories cold, warm and hot. So you should give cold category number 0, for example, and warm category number 1 and hot category number 2, because there are some kind of relationship between these categories, some kind of ordinal relationship. So you should not use one hot encoder here because there is some kind of ordinal relationship between the categories of the ordinal columns. That's it. To do that, you can use ordinal encoder. To do this process, you should add another step here to convert the categories inside your ordinal features into numbers. But here we don't need to add this step because our ordinal feature has just numbers. Finally, let's create our preprocessor. This one will work on all our features. It will use all our pipelines and it will specify the features that we want to pass it through each pipeline. So firstly, preprocessor equal to column transformer, and here we will create our transformers list. Here is the first transformer. Here is the name of this transformer. Let's call it
nominal, for example, and here let's type nominal. Here the first pipeline or the first transformer, it is this one here. Here's the name of it, and the pipeline that we want to use, numerical pipeline, and the features that we want to pass through this pipeline, which are the numerical features. And here the nominal transformer, here we will use nominal pipeline, and we will pass the nominal features through this pipeline. And here finally ordinal transformer, which will use ordinal pipeline, and here we will pass the ordinal features through this pipeline. Now let's create the final pipeline. This one will have our preprocessor and our classifier, our logistic regression model. So model equal to pipeline, and here's the first step. We should preprocess the whole data set. Here's the name of the first step, and here we should pass our preprocessor. And here's the second step, the output from this step, we will pass it through our model. Here's the name of the second step, classifier and our logistic regression model. Okay, let's convert this to nominal. Here we will take numerical features and nominal features and ordinal features. Okay, so we will type x equal to train. Here we will open these square brackets, numerical features plus nominal features plus ordinal features. And here's the target. We want to use it in the training and evaluation also. Now we will divide our data set into training and testing. So x underscore train, x underscore test, y underscore train, y underscore test, train test split. Here we will pass our x and y. And here is the size of our test data, which is 20% of our original data set, and random state equal to 42, to make sure that we will get the same training and testing data anytime you run this code. And here we will train our model on our training data and do predictions on our test data, and here we will find the accuracy. And here is the result. Here is the accuracy after running this code. As you can see here, now our accuracy improved a lot. It is now around 79%, which is very good compared to the previous accuracy. Why? Because here we used all the features in our data set. And as you can see here we are just doing feature engineering. We didn't touch our logistic regression model. We didn't change the parameters of this model. We just pre-processed our data to make it suitable for this logistic regression model, and our results improved a lot. And that's amazing. We will make it even better in the next lectures. Thanks for watching. Hi everyone. In this section we will talk about feature selection. What is feature selection? It is the process of picking the most useful features for our model. Let's say that we have a dataset with very large number of features. For example, 10,000 features. When we want to train our model on all these features, our training will take long time. And at the same time, using this model in the real world will be very slow. To solve this problem, we should reduce the number of features that we want to pass through our model. We will take just the useful features for our model. The features that have very good patterns that our model can rely on to create very good predictions. In machine learning, when you are working with data sets that have a large number of features, it's common to find many irrelevant features, useless features. In this section, we will learn how to find these irrelevant features and remove them from our dataset to make our model faster. In the next lecture, we will do amazing things. Don't miss it. See you there. Hi everyone. In this lecture, we will do feature selection using ANOVA F-test. What is ANOVA F-test? It is just a statistical test that helps us find out how strongly a feature is related to the target variable. This ANOVA F-test gives a score to each feature based on how strongly it is related to the target, and then selects the top K features with the highest scores. Firstly, our task, it is a classification task. We should use the classification version of ANOVA F-test from scikit-learn. So we will type the following: from scikit-learn.featureSelection import F classification, and we should also import select best from scikit-learn.featureSelection. This select best will use the scores from our ANOVA F-test to select the top K features based on these scores. It is very easy to add feature selection functionality in our pipeline. We just need to go to the final pipeline. After our preprocessor step, we should add another step, which is selection step. The name of this step is selector, and here what we will do, we will use select K best from scikit-learn, and we should open these parentheses and passing F classification, and here the number of features that we want to use. Here we want to pass to our logistic regression model the best 100 features, for example. Okay, and here's the result, as you can see here. Now our result, it is better than our previous results. We didn't just speed up our model, but we also improved the accuracy. Why? Because some of the irrelevant features led our model to learn wrong concepts. So by removing them, we removed these concepts, these not generalizable concepts, which helped our model and made its results better. Now, if we want to see the maximum number of features that we have originally, okay, let's go to our final pipeline, model pipeline, and here we will extract the output from preprocessor step from this pipeline. Okay, so we will type named steps, and here we will pass the name of the first step in our pipeline, which is a preprocessor step. And what we will do now, we will type .transform, and here we will pass our training data. We will get this very large array. Let's see the shape of this array. This is the output from our preprocessor step. As you can see here, we have around 127 features. Here we wanted to take just the best 100 features from these 127 features, and here is our result, 81%, which is very good. You can try many different values here to find the best one. See you in the next lecture. Hi, in this lecture we will learn how to do feature selection on categorical features. Previously, we applied ANOVA F-test on our pre-processed data. Okay, we put it this step here between preprocessor step and classifier step, which is not the ideal use of this tool. Why? Because this tool, ANOVA F-test, prefers to work just on numerical features. Okay, it likes to do feature selection on numerical features. It doesn't work good on nominal features most of the time, but sometimes it works, like what we saw in the previous video, which means trying weird idea might help sometimes. Okay, in this video we will use two feature selections tools, ANOVA F-test tool and chi-squared tool. Okay, firstly, in our numerical pipeline, this pipeline will work on our numerical features, our ratio features and interval features. Those features with continuous values, like for example temperature feature, age feature, etc. After the imputing step, we will put our selector. Here we will take the best 4 numerical features from our numerical features, and after that we will do standardization or normalization to our features. Let's go to the most important step now. Let's work on our nominal features or categorical features. Here we will impute the missing values and we will convert our nominal features to one-hot encoded vectors using one-hot encoder. So we converted them to numbers. And after that, what we will do, we will use chi-squared tool. This tool, we can use it with the classification tests only, and it is good in feature selection on categorical features on one-hot encoded vectors, the output from this step. Here we will take the best 122 features, 122 one-hot encoded vectors, and that's it. Now let's see the result. And here's our result, which is very good. It is better than the previous one, which is 82%. That's amazing. Thanks for watching. Hi everyone, in this lecture we will take another way to do feature selection, which is recursive feature elimination. So firstly, let's import this tool, recursive feature elimination, from scikit-learn.feature-selection. Okay, we don't need this one. And yes. Now, this tool will do the following. It will repeatedly train a model and remove the weakest features each time. So now let's use this feature selection tool. This one will work on both categorical or numerical features. So you can put it after your preprocessor step. Okay, like this. Let's call this step RFE step. And here what we want to do, we want to pass the model that we want to use during doing feature selection. Because our task here it is a classification task, so we should use a classification algorithm. Let's use here logistic regression model, but you can change it to any classification model that you want to use. Okay, and now what we will do, we will take just the best 100 features from the output from our preprocessor step, and that's it. Let's see our result, and here's our result, which is 81%. So here we reduced the input features to our logistic regression classifier a lot. We made the number of input features equal to 100, and at the same time we didn't affect a lot on our accuracy. That's really good. Thanks for watching. Hi everyone. In this section we will learn how to use ChatGPT to create new features. Previously we had to create new features manually, which required a strong understanding of the original features of our dataset and domain knowledge, making the process very difficult. Now we can use ChatGPT to automate and simplify this task. You can use free plan or personal plan or business plan. Actually, free plan it is enough here. Here in this text window, we will write our prompt. We will write what we want from ChatGPT to do. Here we put it what we want. Firstly, we want from ChatGPT to create new features from only the numerical features in our dataset. Okay, so I'm working on a machine learning problem and want to improve my model's performance by creating meaningful new features. Previously, manual feature engineering required deep domain knowledge and a strong understanding of the dataset structure. Now, I'd like help automating or brainstorming feature creation using AI. I will provide a dataset card containing column names, descriptions, and optionally some sample values. Please suggest the most useful new features, focusing only on the numerical features, okay, that could improve model accuracy based on relationships, transformations, or external knowledge. Actually, I found the Titanic dataset description in Kaggle community in this website, in Kaggle website. You just need to copy all these things and that's it. Now we will paste our dataset description here and click on this symbol. As you can see here, ChatGPT created many new features like family size feature, is alone feature, fair per person feature, age fair interaction, age class interaction, has fair, and many other new features. Actually, you don't need to understand the meaning of these new features, you just need to know the type of these features, because we want to know in which pipeline we should pass each new feature. But if you want to understand them, ChatGPT gave to us a brief description under each new feature. You can read it if you want. Now, what we want from ChatGPT, we want to write the code below each new feature. Write the code below each new feature. We will try all these features one by one. When we add a feature and that feature improved our accuracy, we will keep it. Otherwise, we will remove it and try another feature. Here is our best accuracy, about 82%. What we will do now, we will take the first feature, this one here. Let's copy this feature and put it here in this place. We will replace data frame with a train, our training data frame called the train, and this one a train also, and this one also train. Firstly, what is the type of this new feature? Numerical feature plus numerical feature plus 1. The results will be also numerical feature. That's it. I think we should check the names of these features. Let's print our original data frame. Okay, let's print the first 5 rows. Here is the name of SIP SP. So let's copy and put it here. And the same thing for Parch. The first letter in the name of this feature is in capital case. Let's put it here. Now let's check. Yes, that's right. Now we have a new feature in our training data frame. What we will do now, we will put it with our numerical features. Let's see our results now. Let's run this cell, and we didn't get anything. Our result didn't improve. So this feature is not that important. Let's go ahead and try another feature. Let's try this one. This feature will be based on our family size feature. So let's copy it. Let's go in this place here. Let's change this to train and this to train, and that's it. Now we have this new feature. Let's see this feature. Let's see what is inside this feature. This feature actually it is nominal feature, and let's change this is a lone feature a little bit to make it suitable for our one-hot encoder. So we will do the following. Along category, we will make this a new column, along category column. Here what we will do, we will replace each 0 in is alone feature with not alone text, and each one value in our is alone feature with alone category. That's it. Let's run this. Now what we will do, we will put this new nominal feature here, and that's it. Now let's run the cell. Our results here, it is not good actually, so we should delete this new feature. After trying many new features, I found that just this H-fair interaction feature improved my results. And this feature actually it is a numerical feature. If you don't know the type of any of these new features, you can ask ChatGPT to tell you the type of each one of these new features. Because as I said previously, it is very important to know the type of each one of these features to know in which pipeline you should pass each one of these features. We should pass this new feature through our numerical pipeline. So we should add this new feature, the name of this new feature, to numerical features list. Let's see our results after training. Our results improved a little bit from 0.821 to 0.8268. And if you want to create another set of new features, you can ask ChatGPT to create them for you and try them one by one, like what we did previously. You might find another useful features for our model. Now it is your turn. Try to create new features to improve your accuracy. See you in the next lecture.
Hi everyone, in this lecture we will create more advanced features by combining categorical and numerical features together. Here is the prompt that I sent to ChatGPT. I just added this part here, new features focusing on mixing between numerical and categorical features. That's it. Let's see the results. Our new features. We tried this one previously and this one also. Okay, you should try these features one by one to see which one is the best, which one will improve your accuracy. Okay, actually the most important thing here is to find the type of each one of these features. I don't care about the description of these new features, but if you want to read it, you can read it. Okay, and as we said previously, when you try a feature and this feature improve your accuracy, in this case you should keep it, otherwise you should remove it. Here are the types of our new features. Okay, we have numerical features and categorical features. Actually I tried all these previous features and the best one of them was this feature, age sex group feature. This feature improved my accuracy from 82.6 to 83.2. This feature, it is categorical feature. If you want to know if it is nominal or ordinal, you just need to copy this code and ask ChatGPT about it. Here I ask ChatGPT about this new feature, age sex group feature, and the final answer was nominal. Okay, that's it. So we need to pass it through nominal pipeline. So we will put it here in this nominal features, age sex group feature, and that's it. And here is the best accuracy, which is 83.2%. Let's give you some tricks. You don't need just to use ChatGPT. There are other choices. Like for example, Google AI Studio. You can send the same prompt to this Google AI Studio here, and you might get another features that might help your model during training. Or you can also use Claude. You can also send the same prompt to Claude. You can use both of them for free. And I prefer to use Google AI Studio. Actually, this process, it is endless. You can try to add new features again and again and again until reaching the accuracy that you want. That's it in this section. See you in the next section. Hi, in this lecture we will talk about PCA, Principal Component Analysis. Let's say that we have a data set with large number of features. Let's say for example 1000 features. And we want to reduce our features to 100 features to make our model fast. We can remove some of our features here, like what we did in feature selection. But let's say the features that we removed, they had important interactions with the rest features. In this case, this will affect on our model during training. So here we will not remove features, but what we will do, we will create new features from our original features using PCA. PCA will create a smaller version of our original data set by compressing our original features. Okay, here these new features, they are created by the contribution of all our original features. So here we didn't remove any column or feature, but we used them. We used all these features to create these new features. In the next lecture, we will learn how to use this PCA in our pipeline. Thanks for watching. Hi, in this lecture we will use PCA to reduce the number of our features. Firstly, we should import PCA from scikit-learn.decomposition. Okay? Here you should know that they built PCA to work with numerical features. So we will apply PCA on our numerical features. As you can see here, we have these 5 features. We will apply this PCA on these 5 features to create a new set of numerical features. Firstly, we should search about our numerical pipeline, which is this one here. And what we will do here, we should put our PCA after our normalization step or after our scaling step, which is something important. You should normalize your numerical features before passing them to your PCA. So we have this new step, PCA step. Here we will type PCA, and here we have this thing here, this argument and components equal to 3. Let's make it firstly equal to 1, which means we will create just one feature from these 5 features. Okay, and that's it. Let's run the cell, and here is the result, 0.815, which means 81%. Let's increase this argument to 2, which means that we will create 2 features from these 5 features. Okay, and here is the result. Let's make it equal to 3. Now our accuracy improved a little bit. Now it is equal to 82. Okay, now let's make it equal to 4. Let's run the cell, and here is our result, which is also good. It is also improved a little bit. It is now 83%. Let's make it equal to 5, and here is our result, the same. And if we make this n components equal to 6, which is greater than the number of our numerical features, in this case it will give us an error. Okay, so you should make the value of this n components argument something between 1 and the number of your numerical features. Okay, so now the best value is 4. Here we reduced the number of numerical features to 4 new features rather than 5, and our results are good. That's amazing. That's it for today. Thanks for watching.